so hard.
Okay.
We're rolling.
So, in case some of you, yeah, like Mia said, she accidentally fell in love with
Optics, yeah.
optics.
How did that happen?
Yeah, me and Noah as well change sides.
You're,
You both
you're
like
in?
it?
It's not bad.
Okay. No.
Hey, so far, I'm apathetic to it.
Okay.
Right,
So-
you're not allowed to remain You're not allowed to remain that way.
Okay. So, let me kind of make sure everybody's cool with what I'm looking for on these assignments, on these diagrams. So, if you look at like,
Okay, let's start with.
I don't know, problem number 24,
Thank you.
okay? So, you got a concave mirror, okay? Now, here's the whole point with concave mirrors, is that, and this is what you have to figure out, especially with concave mirrors. And the lab today is going to deal with mirrors, the lab on tomorrow is going to deal with lenses.
We're doing a lab today.
Yeah. So we've got a lab today.
Yay.
We'll start, I'm going to introduce the mirror lab today. I'm going to introduce the lens lab tomorrow. And then Monday is basically kind of a catch-up day, because I know some of you are going to be gone tomorrow. Keegan's going to be gone. Keegan's gone. Eric's been gone all week. And so, and even with those of you that are. So it's the one day out of this entire class on Monday is just going to be like kind of a catch-up day. Which won't be bad because the Super Bowl is Sunday night.
Oh.
So I'd like to say I had it planned that way. I really didn't. It just worked out that way. So that way, you know, you guys don't have to worry about doing a bunch of homework Sunday night. You can, you know, enjoy the Chiefs if you're a Chiefs fan. Even if you're not, you can enjoy the Super Bowl atmosphere. If not, you can sit at home playing your computer game. I don't care. Okay?
Who's going against the Chiefs?
San Francisco. So.
What? You guys get to play games on Sunday?
Here's the deal. So you got a focal length, 5 centimeter long mascara is held 20 centimeters from the mirror. Use ray tracing to determine location. Is it real or virtual? Okay. So there's two things that obviously I want as an answer. Is it upright or is it inverted? Is it real or is it virtual? Okay. So those are the two things that I'm going to want.
So you don't
Now,
want the distance?
So, well, I mean, it's beyond the distances and everything else, okay? So, here's going to be your mirror. And with this one, you've got a focal length of 40. So you're going to set up a scale. Maybe you're going to let 5 centimeters equal a centimeter, okay? Make sure that I see what the scale is. Just don't randomly draw this thing and think, oh, I'm going to know what you meant. So here's what I'm looking for. So you're going to choose some scale and you're going to go, here's your focal length, okay? That's just going to be a mark. And then you've got the mascara brush, which is 20 centimeters. So that's going to be here, okay? Okay? You can make it look like it a brush, a can, or whatever. It doesn't make any difference. And you don't have, this is going to sound odd, but you don't have to let the same scale going in terms of this dimension. You can use a different scale in this dimension, okay? So you could let like 1 centimeter equal 5 centimeters on this dimension, and you could have a different scale on this one, because that height is just a ratio anyway, okay? So when you have a mirror, and in this case you're inside the focal length, so the ones that I always draw, personally, this is just my own preference, I take this and I flip it over, so like on this scale, that would be like 1, 2, 3, so I'm going to come down here and make a mark. And so the first one that personally I always draw with mirrors is I'm going to come in here, I'm going to draw this line, and then I'm going to draw that line, and then, so one of two things is going to happen with this mirror. Either it's going to be a real image that's on this side of the mirror, or it's going to be a virtual image that's on this side of the mirror. Okay? Those are the only two options. This only happens with concave mirrors. Okay? Convex mirrors, you can only produce a virtual image on the other side. Mainly because if it's a convex mirror, you'll never focus these rays back to a point. They're just always going to be divergent. So because of the fact that this is a concave mirror, it's either going to be somewhere in this triangle or it's going to be somewhere out here. Those are the only two options that I have. So I'm going to go ahead and I'll just draw it a different color. Usually it's done as a dashed line, but changed up a little bit. And we'll extend this line out like this. Okay? Good. So then, the next one I always do, come in here and go, okay, I'm going to draw this line like this, parallel with that candle. And then it's going to bounce and try and go off that focal length. And then we'll change up the color again and we'll extend this one out like this. So here's the deal. So right away, just based upon these two lines of this coming in here, going through this focal point, this coming in here, hitting this, and going back like this. So notice that these two lines right away are starting to diverge. So is there any way that these two lines coming like this are ever going to meet where I can get an image?
No.
No. Now, these lines up here meet. Okay? They meet back up here. So right away it says, oh, this is where this image has to be. Now, there's a couple of things just based upon these two lines I know. The image is going to be upright or inverted.
Upright.
It's going to be upright, and it's going to be big. So, if you think about this, if you're designing mirrors for people to apply makeup, okay, and if you're doing eyelashes or whatever, right, okay, having never done this, I'm surmising, I've got 3 older sisters, I've seen them do this a lot, okay, you really don't want this image to be inverted, okay, it's hard enough, again, I've never put on eyeliner, okay, and we're all good with that.
Yeah.
Yeah.
Fundraising.
Oh, God, no. No.
Dude,
Yeah,
no.
yeah.
No.
No, not just
The
eyeliner.
world will burn. Okay?
Isn't it already though?
Eyeliner does
Australia
not go on
was.
your eyelashes.
I don't care.
Your
Well,
eyelashes really.
well,
Whatever you're
it
putting on your
depends.
eyelashes,
If
okay?
you're out of mascara,
Mascara. Okay.
if you're out of
Again,
mascara, then
not
you have to,
not my wheelhouse, okay?
Well,
Okay?
Fundraise. Yeah, how dare you not?
But I would surmise if you're putting mascara on your eyelashes, it's hard enough as it is, let alone if the image that you're looking at is upside down. Okay? I'd imagine that would be tough to do, just surmising. So if you're designing a mirror for people to use in applying cosmetics or doing detailed work, you don't want a mirror that's going to flip this thing upside down, okay? You want it to be, because then you're still upside down. You're just upside down here, upside down, and then you're just going to get rid of it, okay? So, here's at least 2 diagrams, or 2 rays. You could actually have like a third one, okay? Where it comes in, you could draw one where it comes in, here's that focal length, you got that one.
down this path.
Okay, so anyway, so you're going to have something out here. So, focal length, I want this labeled as your object. This is going to be your image. And again, the idea being, in the spirit of this lab, or these diagrams, is that you actually measure that, and you work backwards from your scale to say, here's my image distance, and this is my height. Okay?
So you want the height for, you also want the height. Okay.
Yeah.
Oh, I didn't do that.
Because on the question it only
It
really.
didn't ask for the height on the question.
Nope.
Yeah, it didn't. No. For 20 and 22, no.
For 24.
Oh,
it
and
did.
24 it did. Yeah.
It's just for 24 that it wants. to
Okay.
Yeah.
Okay, that's why I was confused. I thought you wanted it on mine.
No.
Okay.
So anyway, on 24, it should be about 40 centimeters on the back side of the mirror. That's where it should appear. It's not actually there, but it just looks like it is.
It's not actually there.
Just saying.
Because it's a virtual image.
On
right?
28, your that one with the rear view, focal length of 2. The location of the image on 28 should be between 1 and 1.5 meters on 28.
28 should be what?
Your image distance should be between 1 and 1.5 meters. Now, once you get past that, once you get to 30, 34, 36, if you wanted to make a sketch, you can, but those are just also just basically using that thin lens equation. It's just a matter of knowing what. So anyway, so on 30, there's two things you want on all of those 30 through 39. You want the image position and the height, okay? So on 30, your image position should be 40, okay? On 34, your image distance should be between 5 and 10 meters, or 5 and 10 centimeters.
Yes.
On 36, it should also be between 5 and 10 centimeters. On 38, that image distance should be between 35 and 40.
Yes.
And on 39, well, the answer's in the back of the book on 39.
For the height, should we write it, if it is negative, as negative, to also denote that it's inverted?
That's up to you.
Okay.
Yeah,
It's more the magnification that tells us if it's inverted or.
yeah, whether it's negative or not, if the height is negative or not has no bearing on whether it's inverted or not.
Yeah.
So, I just going.
It's just, all I want is just the height. So
You don't
that's
care if it's
something-
positive or negative?
No.
Okay. So, it's only
Okay.
24 and the other problems that you don't draw, that call for height, yes?
What?
It's only 24 and the other problems that we don't draw for that call for height, yes?
Yeah, the 24 is the only, if they don't ask for the height, you don't have to give it.
Okay.
Okay, are we good? You kind of getting the feel for what's happening? Okay.
Light does weird things. That's the light's whack.
Light? Your light's whack, bro!
So one goes horizontal, pushes off the mirror, and goes in the opposite direction of the and there's one that goes towards the and not horizontal.
Okay.
And then there's one that goes towards the center and commit left. I'm not sure.
Well, I got 60 centimeters. Is that wrong? On 24?
I wonder why. I really wonder why.
32 and a half.
This is 2 lines in.
What does that mean? You can't start a conversation with that.
Stonks. You know what stonk is?
Mirror, mirror on the wall. Who's the craziest of them all?
Jerry King. Is this multiple lines?
Oh, pages.
I don't like the pages.
Mr. Bergkamp? With those words, you have scared this entire row. It's just one, you scared the entire row with that phrase. By saying that it's just one lab. All these pages.
Concentrated there.
The sheer size.
License?
Well, that's not what I got. But I think it's this one.
Yeah, mirror, wall. Who's the fairest?
Okay, Mia, we're still going?
Mia.
Yes.
I already told me.
Mia.
I told you.
All right, so let me kind of explain what's going to happen with this lab. So, you're going to, let me start again. So, here's the deal. You're going to take a concave mirror, and you're going to have two different mirrors in your setup. The concave mirror, it'll make sense, is going to be one that's going to be on an axis that you can rotate around like this. Okay, the convex mirror is just going to be a fixed one. That's the easiest way to tell the difference, because it's odd, they really don't label them, but that's going to be the difference. So here's what I want you to do first with the concave mirror. So you're gonna arm's length, hold it out like this, see what you can see. Then you're gonna write down, hey, when you look at that, is it inverted? Gradually move the concave closer to you. How does this affect the image that you observe? Okay. So then you start out here, and then you're going to bring it closer and closer and closer, and you're going to tell me, hey, does it stay the same? Does it flip over? Does it get smaller? Does it get bigger? Does it fade out? What happens? Okay. So then you can do the same thing with the convex mirror. Okay. So the convex mirror is going to be the one that's locked in place. So again, you're going to start with the convex mirror out here like this, and then you're going to bring that in, and then you're going to tell me what's going to happen with that. Again, is it upright? Is it inverted? What takes place? And then you got some answers. Which two mirrors lenses can produce both real and virtual images? Which two mirrors lenses can only produce virtual images? If it is inverted, what's the sign of the magnification? If it's upright, what's the sign of the magnification? Okay, so that's all just kind of general knowledge kind of thing. Start, hold it out, take your time, okay? And this is something that, I've got 4 setups, so it's like 16 of you, okay? That's 4 persons per group. You've got a lot of time on this. This is one of those deals that don't let just one person do the lab, and then everybody else sit around and just write it down. Okay, because I've seen absolute train wrecks happen because one person will have the wrong side and they're gonna do this, and everybody in the group actually has the exact same wrong stupid answer. Okay, so this is literally a visual type lab. So take your time, actually do this, see what happens when you actually do the lab. Now, when you get to the lab itself, me bring the camera, let's actually go to the back.
Field trip.
Seriously though, why am I the camera person?
Because you're right next to the camera.
Yeah, but I'm.
And the entire year.
Yeah, but I'm so short.
Do you always wanted to be a videographer?
No, I wanted to be on the other side of the camera.
What?
I'd rather be an actress than a person filming. Oh, business.
It's like no. It's like no.
Now, I got this. Get my head.
Okay.
Are you alright?
Hello. Hey, do you ever get questions on your YouTube channel? And if so, do you answer them? No? If you ever got
Hip. Okay, so what you're going to do with this one, so there's 2 parts to the lab. You're going to have the concave side of the lab, and then you have the convex side of the lab. So, and within the concave part, there's 2 parts to that. So the concave is the one that you can, this is this pivoting one. So, and you have to set these up exactly where I tell you to. So you're going to have the light source here at the 10 centimeters. I tell you this all in the lab. Then you're going to have the mirror out here at 110. So you've got a distance between the source and the mirror being 100 centimeters. So is that my SI or is that my SO?
SO.
SO. So I got to, and that's what's on your lab. So if you look at that column, I'm telling you what I want the object distances to be. You don't have to fill that in. That's already there. Now, what you're going to do is, once you get this set up, you're going to, and you got this half screen here. And so when you tilt that, you're going to make that 4 appear on this half screen. So what you want to do is you want to adjust this so that this thing becomes into focus. So you can bring it closer, okay? And there's going to be a point where it's just going to come right into focus, okay? So maybe get an idea where that is, and then like approach it from the other side, okay? So that way you kind of make sure that that thing is exactly where you want it to be. So then you're going to be able to measure the image distance, okay? So it's like, okay, hey, here's my object, here's my image distance. The other thing that you want to measure on this chart is the height of the object, okay? Well, you got that one. That's never going to change because you're going to be using the same 4, so measure that. Now, the image distance is a little bit dodgy because your image distance is that you have to measure the height of that 4, okay? So it's tough to get like a meter stick in there and try and measure that. So what I would recommend is maybe taking like a scrap piece of paper and putting that in there, and then you can get an idea, like make a mark on the paper in terms of the height, or just something.
Would this work?
If you can get it in there, yeah. So, but that's going to be the trick, is that you're going to measure that. So you're going to get these dimensions. So your object distance is always going to, but that's what I'm going to give you. You're going to go from 100 down to 60. Your image distance is going to change based upon your setup. What you're calculating actually is the focal length. Okay, so one of the things that's actually is the anomaly on this one is that you don't know what the focal length of the lens is. That's what you're going to try and calculate. Theoretically, it should stay about the same even as you're changing these dimensions, because it's a fixed value based upon the curvature of the lens. Okay. Then you got your HO, your HI, and then you're going to have your magnification. Okay? Cool with this. So then you're going to shrink this, then you're going to go back to 90. So you're going to move this from 110 to 100. Okay? And then you're going to adjust this so that that comes into focus. And then you're just going to keep going like this, like this, like this. Okay?
Yep.
Got that one. Okay. Now, the second part of the lab, over here on page 3. So I'm going to tell you to remove the half screen, make that go away, and you're going to go move this really close to this. So with this one, what you got to do is that, because what you want to look at, watch out, is you want to, and you got to kind of get back over here, and you're going to turn this mirror so that you can see the 4 in the mirror. So you got to get down on this level, which is hard for an old man. Okay, and you're going to see that 4. So this is why you do this, where you can turn this. You can turn this and see that 4. So what you want to do is kind of bring that a little bit closer. Okay, you actually want to start with it far away, and you won't be able to see anything. But once you cross like a threshold, then you'll be able to see that 4, and then you're just going to kind of bring it in increments and observe what happens to that 4. Okay? So the first part of the lab, you're going to have the half lens in, and you're going to project that on. The second one is just, you're not going to have the half lens, and you're just going to, and your eye is, that's what you're looking at. So that is going directly to your eye. But it's kind of weird, you have to get over here like this and do that part. Got that? Okay, now, let's go over here to the next part.
A field trip.
Okay, now, out of everything that I'm going to teach you this entire year, this is the hardest thing to begin to explain what's going to happen, okay? Literally, this is tough to do. Because either kind of you see it or you don't see it, okay? And I cannot explain how you see it. Which you're going, Bergkamp, this is just weird, but just trust me on this one. So, first off, this is going to deal with this concept of parallax. So here's a quick example of parallax. If you close like your left eye and hold your thumb up out in front of you, see where that lines up on the wall, right? Now, hold your thumb steady, and then close the other eye and open the other and switch out. So what happens to your thumb?
It moves.
Your thumb moves. Now, if you bring your thumb closer, what happens to that apparent shift?
It lessens.
It grades.
It's great.
It gets greater, right? Okay.
Yes.
So the further away it is, the less the parallax shift, because of the fact that if you do the ray optics, okay, and this is actually one of the first things that they used to determine the distances of stars was parallax, because if you consider the sun and the earth being here, you're looking at the earth at a distant star going like this. 6 months later, the earth is over here, and you're looking at that same star. So the closer that star is, the bigger that parallax shift. The further away it is, the smaller the parallax shift. So your eyes are like the earth on either side of the orbit, separated by 6 months. Okay, it's got the idea of parallax. Okay.
What about zero lap?
Huh?
Are we gonna have to deal with zero lap too?
With what?
Zero lap?
It's
It's
parallax backwards.
it's basically the
No.
inverse of parallax.
No.
Are we
You
gonna?
won't.
We don't
Okay.
have to deal with that.
No. Okay.
Thank heavens.
All right, so here's, this is what I said, this is tough to do. So what you've got to do is you've got to get down here like this. And what you're going to do is you're going to look through here. At the same time, you're kind of looking over here, and you've got the convex mirror right here. So here's the trouble with trying to get an image distance on a convex mirror, because it's behind you, okay? So it isn't like I can hold up a meter stick and go, oh, there, now I got it measured, okay? No, it's behind you, all right? Because that light is hitting and it's bouncing off like this. So bear with me when I try to explain what you're going to see. So when you get here, and the whole key to this is that you're looking at, when you look at this, you're going to see this half image in the mirror, okay? Now, what you want to do is, because you've got to line up like 3 different things. You got to look through this and see this image. Then you're going to see where it's going to fall on the mirror. But then you're also kind of got to look at this blue line that's on the index card that's up above. So you're looking, and this is what I said, this is incredibly difficult to explain, so just bear with me. So you're looking here, right, and you're seeing this line up with this mirror, you're seeing this image because it's reflecting back. Then you're also looking at blue line up there. So what you'll see is that this line appears to be to the right of this half screen. So when you move over, and this is where the parallax comes into it. So when you shift your gaze over, you should see that this line then moves relative to this division line, okay? But again, you're looking at like 3 different things at once. So start with it really, really close because that's easy to see. So then, as it goes further away, then you're going to do the same thing, okay? So you do the same thing, you're going to kind of line it up, move over a little bit, and then you should see that the shift becomes a little bit less. Move it again a little bit farther back. What you should see is that once it gets far enough away, you don't have any parallax shift, okay? Because it's gone so far beyond that, what you can see that that shift goes to 0. So here's the hard part. Unlike every other part of this lab, you're going to go until something becomes in focus. Like with the 4. Oh, okay, hey, we're going to move the screen until it comes into focus. Oh, we can measure the different things. You can't do that with a convex mirror in terms of being able to measure like the actual distance or being able to measure like the size of the image. So what you're going to do is move this back a little bit. And like I said, some people will see this, okay? And hopefully some member of your group is able to go, oh, okay, yeah, I kind of see what's going on. Because it's kind of like, they used to be really popular where you would have like this kind of random things on a print, and if you stared at it, you would see like a horse.
Those, yeah.
Okay? It's kind of like that. And kind of you either get to the point and you can see it, or you can't. Now, I'll tell you this, if you get to 20 centimeters, that's too far. Okay, so this distance should be less than 20 centimeters. Okay, so if you've gone 20, 30, whatever, you blew right past it. So I'm going to tell you it should be somewhere between 10 and 20 centimeters. Okay, but like I said, out of everything that I will ever teach you this year, this is the hardest to explain because it's like you kind of either see it and you see that shift, or you don't, and because I can't like get in your head and go, oh, okay, well, come on, can't you see it? It's right here, come on, you know? Yeah, and so that's it. So you've got 2 distinct parts to the lab. I don't care which part you start with first, okay? You've got a bunch of ray diagrams that you have to draw. I make sure that because you all might choose different scales on your ray diagrams, make sure that I see what that scale is. What I would do, and let me give you a hint, I would make just a rough sketch of what that ray diagram is gonna look like before you actually put it on paper, because I've seen this happen where you don't choose wisely in terms of the scale, and then your object then, or your image ends up like off the page because you didn't choose the scale right and you didn't start far enough to the left or far enough to the right, okay? So I would get an idea of what that thing is gonna look like before you actually start drawing it on the paper. Or otherwise you're gonna be going, oh man, I started on the right, it's gonna go even farther to the right, and I'm screwed, and now I have to start all over again. So, all right, so I'm done. You're on your own.
Okay,
Mr. Berger,
What?
may I use the restroom?
Yeah, go.